Today I'm going to be talking about lab-grown meat or cultured meat, animal cell-based meat. There's a bunch of different names for it, but to kind of start off, I'm going to give a little bit of background into why distancing ourselves from real meat is an important thing to do. Livestock production accounts for about 14.5% of global greenhouse gas emissions from human activities. And the estimated amount of land that is devoted to livestock production ranges to roughly half to three quarters of global agricultural land, while animal foods account for only 18% of calories and 25% of protein in the global food supply. And if the consumption of meat, dairy products, and eggs were to be halved, nitrogen and greenhouse gas emissions could be reduced by 25 to 40%, and the intake of saturated fat may decrease by 40%. It has been found that greenhouse gas emissions to support a high red meat diet are nearly twice that of vegetarian diets. And the reason that this is important is because climatologists calculate that to avoid heating the earth more than 2 degrees Celsius from pre-industrial levels, greenhouse gas emissions must be significantly reduced. So by creating less of a dependence upon meat industries, especially the beef industry, that could have a really positive impact on the climate. So in addition to the environmental impacts of the meat industry, there are also ethical implications of the meat industry. And I know a lot of people are vegetarian and vegan for the reason of how these animals are treated. Between 1961 and 2014, global production of land animals for meat increased from about 71 million tons annually to about 318 million tons annually. And over 9.5 billion terrestrial animals were slaughtered for meat in the United States in 2017, with a global estimate around 75 billion animals. And global meat production has increased over 4.5-fold from 1961 to 2018, which is nearly twice the rate of population growth. In addition to this, most operations raise animals in very crowded facilities, often in confined crates or cages without outdoor access or the ability to exhibit their natural behaviors. And animals in many of these cases are subject to painful bodily alterations, often without pain relief. These can include things like debeaking, dehorning, and castration. With global population growth and economic development, the demand for meat is expected to double by 2050, and this is just an entirely unsustainable practice. Another negative implication of the meat markets and eating meat regularly is that growing body of evidence has associated red and processed meat consumption with a lot of chronic diseases and early mortality. Red and processed meat consumption has also been associated with increased risks of heart disease, type 2 diabetes, and certain cancers. And beyond this risk to consumers, workers in industrial food animal production operations may be exposed to zoonotic pathogens, including antibiotic-resistant strains, and there's also a wide range of airborne hazards. An estimated 1 in 4 workers in indoor confinement operations suffer from some form of respiratory illness. Animal slaughtering and meat processing workers are often required to perform strenuous labor for long hours under hazardous conditions and face high rates of injury and illness. Now that we've gone through all of these negative implications that are derived from the meat industry, I'm going to touch on a couple of plant-based alternatives and then talk about how cultured meat is seeking to combat a lot of these negative implications of meat. So lately, plant-based substitutes for meat have become a very profitable market. The global market for plant-based substitutes is projected to reach $85 billion by 2030, up from $4.6 billion in 2018. And in general, a lot of plant-based substitutes contain comparable amounts of calories, protein, and iron as the meats that they are intended to replace. Ingesting a lot of soy food has been associated with improved blood lipid levels, moderately improved bone health, reduced risk of type 2 diabetes, and decreased breast cancer risk. Plant-based diets have also been associated with more diverse gut microbiomes than omnivorous diets. And this is largely due to the compounds and characteristics of whole plants consumed in plant-based diets. So, one review of a bunch of literature found that the footprint of plant-based substitutes is 93% smaller than beef from beef herds, 87% smaller than beef from dairy herds, 63% smaller than pig meat, and 43% smaller than poultry meat. In addition, the land use footprint of plant-based substitutes was 98% smaller than beef herds, 89% smaller than dairy herds, 82% smaller than pig meat, and 77% smaller than poultry meat. In addition to that, they also use less fresh water than is used in meat production by pretty significant standards. One study found that conventional pork production involved 1.6 times more pesticide use per unit of protein compared to the production of a pea-based plant protein substitute. And another study found that conventional meat protein required 6 times more biocides, which are pesticides and disinfectants, to produce in the same amount of a soy-based plant-based substitute. It has also been found that producing legumes, which is a primary protein ingredient in most plant-based substitutes, can improve soil biodiversity. This soil biodiversity, in turn, will promote resistance and resilience against disturbance and stress. It improves water and nutrient use, efficiencies in crop production, and suppresses soil-borne diseases. And right now, declining biodiversity of agricultural systems is a concern for long-term food security and resilience. This is threatened in part by monoculture production systems and genetic uniformity in crop varieties right now. Now I'm going to talk about the process of making these cell-based meats. So, just like a farmer chooses their best cattle to go to the butcher, the best and healthiest cows are selected to collect cell samples from to help grow the meat. And these cows, after the cell sample has been taken, the cows are free to roam, free to do whatever, and they will only take a sample that is about the size of a peppercorn. So it's very small, a 0.5 gram sample, and it's taken under anesthesia, and it's a standardized veterinary procedure. And this one sample has the potential to create 80,000 burgers. To create this replication of a natural environment where the cells would be growing naturally on a cow, the samples are placed into industrial scale bioreactors, which are used to proliferate the myoblasts, and these cells undergo a differentiation and maturation process supported by a scaffolding process to form the final lab-grown meat. And so the muscle cells that are grown in a growth medium, the muscle cells merge naturally and create about these 0.3 millimeter long fibers. And these fibers from one sample will grow to about 800 million strands of tissue. So one thing that's kind of been a struggle to figure out is the mechanical support that cells get from collagen structures. And some of the earlier attempts to kind of figure out these collagen structures and how to replicate them were using things like spinach leaves and artichokes, leaving only their structure behind. And now gelatin, mushroom roots, and textured soy proteins are also contenders to build the best, most realistic cuts of meat. And something that's super interesting about this lab-grown meat is that fat and cholesterol levels in the lab-grown meat can actually kind of be controlled, leading to potentially positive health outcomes, since heightened blood cholesterol levels can lead to conditions like cardiovascular disease. Lab-grown meat can be fortified with vitamins and minerals to deliver maximum nutrition. With that, you can see that there can be some health benefits associated to this lab-grown meat compared to regular meat that you might get from a cow. If you think about it, essentially there's going to be no mercury, no microplastics. It's going to be the most pure sample of protein, of muscle that you could get. There are a lot of the pathogens that are responsible for foodborne illness, like Salmonella, E. coli, live in the guts of animals, and pathogens of animal origin can enter the food supply via multiple pathways, such as if manure is transported via runoff onto nearby produce foods or contaminates water sources used for irrigation. More directly, if animals' digestive tracts are accidentally severed during processing and slaughtering, the spilled contents may contaminate meat with the potential for widespread cross-contamination. Cell-based meat is known to be healthier, safer, and disease-free compared to farm meat. Also, transmission of zoonotic diseases may decline if cell-based meat production reduced human-livestock interactions. It is said that if cell-based meat production is to increase, the costs of therapeutic and biomedical technologies relying on cell tissue engineering could be decreased. This is because we would have affordable, large-scale cell-based meat production because we'd know how to replicate these cells really well. And that could contribute to major scientific discoveries. Now, let's take a second to talk about the environmental implications of having a dependence upon lab-grown meat, cell-based meat, cultured meat. So, it is said that one of lab-grown meat's biggest environmental bonuses is its land use, given that it requires 95% less land. Over a 100-year time frame, the greenhouse gas footprint of cell-based meat was projected to be between 51 and 97% smaller compared to conventional beef. These are obviously massive strides towards fighting climate change, because if we could reduce the greenhouse gas emissions of the meat industry by 97%, then that would have massive implications on fighting climate change, seeing that it accounts for 14% of greenhouse gas emissions. Everything is 100% good with lab-grown meat, and there are some potential negative implications. So one report speculates that half of the 1.2 million jobs in the U.S. beef and dairy production industry could be lost by 2030, partially because of the lab-grown meat industry, and that farmland values could collapse by 40 to 80%, due largely to its projections that modern protein foods will be 5 times cheaper than existing animal proteins. Another point of contention is, since the vast majority of cell-based meat companies are owned by agribusinesses or biotech startups headquartered in predominantly industrialized countries, meat alternative industries could perpetuate economic and political power disparities between the global north and the global south. Also, as meat is a deeply institutionalized part of Western culture, standardized consumption of lab-grown meat would require some amount of considerable change. While plant-based alternatives have become more popular, there's still going to have to be a required degree of social institutional change to accept eating lab-grown meat regularly. I myself conducted a little study. I asked 28 members of my friends and family if they would eat lab-grown meat, cultured meat. I didn't give them any background on the topic, nothing like that. And I got the results that 14 of them said, yes, I would eat it, and 14 of them said, no, absolutely not, that's gross. One study found that the more people learned about cell-based meat, the more likely they were to think of it as something that they would actually try and possibly eat regularly. So, after hearing all of this information, I hope that you consider trying lab grown meat once it goes on the market, and I hope that this has given you a little more clarity on what lab grown meat is made out of and the societal, environmental, and personal implications it could have on your life.